Alexandra Witze es corresponsal para las revistas Nature y Science News. Escribe noticias y artículos principalmente sobre ciencias de la Tierra, desde su base en Boulder, Colorado. Escribió con su marido Jeff Nape el libro Isla en Fuego, sobre la extraordinaria erupción del siglo XVIII del volcán islandés Laki. Alex es una escritora de ciencia conocida a nivel nacional. Sus reconocimientos incluyen los principales premios de periodismo de la Asociación Americana para el Avance de la Ciencia, la Unión Geofísica de Estados Unidos, el Instituto Americano de Física y la Asociación Nacional de Escritores Científicos. Su trabajo como reportera la ha llevado, entre otros lugares, hasta el Polo Norte, a una zona de terremotos en China y a ruinas mayas en la selva de Guatemala. Está en la Junta Directiva de la Asociación Nacional de Escritores Científicos y en la de The Open Notebook. Entre 2005 y 2010 se desempeñó como editor de artículos y noticias y jefa de la oficina de Nature en Washington, de la revista semanal internacional de Ciencia. Alex también ha trabajado como reportero de la ciencia en el Dallas Morning News, en Texas, y como editor en la primera revista de la Tierra en Wisconsin. Ella tiene una licenciatura en Geología del MIT y un certificado de posgrado en Comunicación de la Ciencia por la Universidad de California, Santa Cruz. Y ahora compartirá con nosotros la conferencia titulada Cazadores de sismos, los hermanos de Plutón, Deja correr el río. Recibamos con un aplauso a Alexandra Witze.
Good morning. Thank you for making it early on this morning. I'd like to thank Jesus for the invitation and to the conference organizers for making this such a pleasant experience. This is my first time to this seminar, and it's been lovely and very informative, so thank you for having me. I thought I'd talk a little bit today. You heard Alex Freeman a couple days ago talking about her work that won the AAAS Kavli Award, and tomorrow you'll also hear Nathaniel about his work. I'm going to talk about some pieces I wrote and how we chose them, how we went about reporting them, and hopefully there'll be some lessons in there for perhaps some tips and tricks for yourself as journalists moving forward. So, you've already heard this background. I studied geology just a little bit as an undergraduate and then went to journalism school after that. And I've focused on earth and planetary sciences as a reporter because of that background I have in geology. I'm currently living in Colorado, as you heard, and my two biggest clients are Nature and Science News magazines. I'll talk a little bit about them and how they fit into the science journalism ecosystem. This again is the award that you've heard about. Basically, it's run by AAAS. It's funded by the Kavli Foundation as well. They have categories in newspaper, magazine, radio, online, and others. And the purpose of this award is to recognize clear and accurate reporting in the sciences. And I'm going to go through in detail these three stories that I wrote. The Quake Hunters on the left for Nature, Let the River Run from Science News, and one called The Pluto Siblings for Nature. I thought I'd talk a little bit about the different publications I write for and how having different audiences means I have to tailor my reporting and my writing strategy to that. So again, my main client is Nature. As many of you know, it's one of the leading science journals. Every week it publishes out of London. It's been doing so since 1869. It has an amazing history, sort of very steeped in the very British Royal Society tradition of leading men of science coming together to talk about their findings. But it has evolved quite a lot in the century or more since then. Our current editor is very interested in issues of social sciences and inequality in the sciences, and much more reaching out beyond just basic, men of science findings. Beyond London, we also have offices all around the world and across Europe, across Asia. In the US, where I work, there's offices from San Francisco to New York and Boston and Washington, where I worked for a number of years. Because Nature is a technical publication and because it is so international, it's a very different type of writing than science journalism for the public. So our readers at Nature are working scientists. They're people who are in the labs, doing the experiments, writing the code, collecting the fieldwork, writing up the publications, and trying to get that covered. It's not just the general public who are interested in science. Our readers are global, roughly a third in the Americas, a third in Asia, and a third in Europe. And it's a bit of a strange beast because if you've heard of Nature, you've probably heard of papers being published in Nature, where the scientists come and report their findings and publish, their new fossil hominid that they found in Indonesia, or the new CRISPR gene editing technique. They're publishing the very technical details, those horrid papers that we heard about yesterday that we have to translate into actual English. So within that broader ecosystem, which is mostly run by PhDs and actual scientists, we have a team of about 12 people who are the news team. We have about 8 or 9 reporters, I guess it's a bit more. We have 8 or 9 reporters and 4 to 5 editors. And we are spread around the globe. Most are in London or in DC, but some of us work remotely or other offices. And our purpose as the reporters is to provide independent journalism on what's happening within the world of science. So sometimes that means we are at odds with maybe what the journal itself is publishing. We may be writing a journalistic critique of a scientific paper that's going into the magazine. So we have a bit of a tension within the publication that's unique to these journals. This is an example of where we run our stories. So basically everything goes up at this landing site, nature.com/news. We have fought really hard to make this independent, visually and graphically independent from the actual journal site, which is just nature.com. So that has all the technical science stuff, and we try to put the journalistic content here. And this is just a sample from yesterday of the types of stories we run. So I wanted to talk through a specific example of a big multi-person reporting project that we did and how we went about it. So this is Pluto, the 9th planet, the dwarf planet, the not a planet, whatever you want to call it. In 2006, as many of you know, and many of you have probably reported on, NASA launched the New Horizons mission to Pluto. This was the last unexplored planet. It was the last world whose face we had not seen. It took 9 years to get there because Pluto, of course, is at the very end of Mars, Jupiter, Saturn, and so on. So we had a lot of time to think about how do we cover this momentous moment in space science. We knew that everybody in the world was going to be covering what happened as the mission flew past Pluto. It didn't go into orbit because that would require too much fuel, but it basically did a super fast flyby. Within 24 hours, just zipped over the surface and kept going. And so we knew this was coming on July 14th of the year. So what do? Well, we have an amazing graphics team. Maybe this is too small, but you can see this was a double-page spread that we did in the print magazine describing the flyby and what was going to happen. In the upper left, that's just a diagram of the solar system with the sun and then all the planets going out. So you can see how long it took, that 9-year journey, all the way to get to the edge of the solar system. At the center bottom, we have an artist's illustration of what they thought Pluto might look like. Nobody had seen it. Nobody knew what it was made of. We had no idea. Above it, we have a graphic of the spacecraft itself, and then heading off to the right is an illustration of how that spacecraft would do sort of a dive bomb through the Pluto system. The rings you see are the moons of Pluto. There's one very large moon, Charon very close in, and then smaller ones farther out. And then in the lower right are various pretty technical details about how Pluto and Charon were formed and why they're unusual as a planet-moon pair in the solar system. So again, this was kind of a scene setter. Now everybody did this kind of scene setter. You know, the New York Times, the Washington Post, Science, all of our other competitors were also writing what's going to happen on the day of flyby. So we wanted to know what are we going to write that they can't get anywhere else? This is all our problem, right? Everybody's writing the same story. How do we bring that added value to the story? So we sat down and brainstormed and thought, and I said, hey, what about if we talk about two of the people involved in the mission? This is not the head scientist. The head scientist we had profiled back when the mission launched in 2006, so we couldn't write about him again. So Elliot and Leslie Young are a brother and sister, and they both work on the Pluto mission. They have a very interesting life story. Their father is also a famous scientist. He was a space scientist at MIT who was very involved in studying health of the astronauts, what happens to the body in microgravity, what happens to aging, what happens to bone density. And he was actually shortlisted for one of the scientists to fly in space, a program that never actually happened, but he was a key space scientist. And his kids, my God, they're so smart. They're these whip-smart, incredibly technical coding geeks who have really shaped our understanding of Pluto and what it's about. In the late 1980s, Leslie was on the plane. The Kuiper Airborne Observatory flies above the Earth's atmosphere, and it flew in the shadow of Pluto as Pluto moved in front of a star. And by watching how that happened, she was on the team that discovered that Pluto had an atmosphere. So here she was making a key discovery about something at the edge of the solar system from a plane flying above Earth's atmosphere. At the same time, her brother Elliot was making some of the first maps of Pluto's surface. This is back in the late 1980s, early 1990s. We couldn't see it. It's too far away. It's this incredibly dim dot. But he had some very clever ideas about how when Pluto and its moon Charon moved around each other, you could start to extract information about what the surface of each one looked like. So he started to map Pluto, even though we didn't know what it looked like. And both of these scientists happen to live in my hometown. There is a planetary science research institute in the town where I live of Boulder, Colorado, which is also a university town. So I said, hey, they're local to me. They're like, who has brother-sister scientists, right? That doesn't happen every day. So we wrote a profile about them. It's not every day you get a science mission going to a planet that's never been there before, and there's a brother-sister on the team. So I wrote a 3-page profile, starting with their scientific upbringing, with their father, with their family, with the kind of, incredibly geeky science things they used to do when they were growing up. We talked about their role in the early Pluto discoveries and how, when New Horizons flew by on July 14th, 2015, it was going to be the culmination of their careers. So this was a way to try to bring the momentousness of this occasion down to two people, brothers and sisters, their family. I mean, we wrote about how their dog was named Pluto and all this kind of stuff. And it was a way to set up what was going to happen during the flyby from a different perspective than everybody else was doing. So that's why I think this story succeeded and touched a lot of people. We got a lot of reader comments, a lot of people who had just spaced out on all the Pluto, pun not intended, who had just been overwhelmed with all the Pluto coverage, were able to look at this story and think about what it means to be people involved in the course of discovery, how researchers' lives and their personal lives are tied into what they're trying to discover about the universe. So that's why I think that particular story worked. I should point out that I had known about Elliot and his sister Leslie for almost 20 years. when I was in college at MIT, Elliot was one of our resident tutors in our dorm. So he was kind of the graduate student in charge of keeping all of us undergraduates in line. And I had never thought about the work he was doing at the time. I was just a college kid. You know, he was the one who would buy us pizzas every Friday night. And all the while, he was doing this cutting-edge scientific research, which I hadn't realized. So for me as a reporter, one lesson I took away from that was that there are people that you know or you interact with who maybe have stories that are relevant to your journalism and what you're trying to write. Because 20 years ago, I never would have thought I'd be profiling pizza guy Elliot as this, incredible space scientist, but he was. And so I was able to revisit a story that I had learned about many years earlier. So that's one of my lessons here, is that sometimes things come around again and they become stories that you can write many years after you know somebody or something happened. It will come back and there may be a reason to write about it again. Also, for the Pluto flyby, sure, we did that one infographic about how the flyby would happen. And sure, we did one profile of this brother-sister team. And we thought that was pretty cool, but that wasn't enough, right? Because everybody was writing Pluto. So we, as a news team at Nature, strategized and planned out a whole bunch of stories running up to July 14th. In the end, we sent one reporter, myself, one editor, and one photographer to Mission Control, where the Pluto mission was being run out of. That was in Maryland. So we set up a whole bunch of activities. We had scientists ahead of time. We arranged for them to come and answer reader questions online. So we had sort of an hour of live Q&A with scientists. It was a very strange time because the flyby was happening. We didn't know what the mission was seeing as it was doing the flyby, because it takes 4.5 hours for the radio transmission time from the edge of the solar system back to Earth. So we knew it was flying by the planet it was like 8:20 in the morning or something, local time, but we didn't have any pictures back. So we had to fill time with content when we didn't actually have any content, right? We weren't gonna get the pictures back for another couple hours. So that's why we decided to bring in planetary scientists to answer reader Q&As live. We thought that would fill time. I did a live blog where I just rounded up not only what our scientists were saying, but what people were tweeting about, what I was seeing at Mission Control at the Applied Physics Lab. And then we were pulling in photos from our photographer at the same time. And my editor was also pulling in other tweets and other reports as well. So we had this live stream going. It was incredibly intense, but I think it was very effective in covering a moment where there was intense public interest, but we actually, like I said, had no actual content since we didn't have the pictures back from Pluto. So we worked really hard to capture the intensity of the moment. These are from our photographer who came out. I love this kid on the left. So they had these spacecraft hats. You could put on the New Horizons spacecraft hat and get your picture taken, and the kids loved that. In the upper right, this was at the moment of flyby. There was essentially a time at which we knew the spacecraft would be at its closest approach to Pluto, even though, again, we didn't know, we weren't in contact with it. And this was this kind of staged moment of that moment. This is Alan Stern, the mission PI, in the middle. There was so much fist pumping and American flag waving. It was kind of ridiculously patriotic. And then in the lower right is Fran Bagenal, a mission scientist who is an amazing source. She is full of anecdotes and bubbly analogies. She's kind of the source as a science journalist you dream of. Like, everything out of her mouth is a quote. It's like, oh, don't stop talking, please. So we had photographs, we had coverage, we ended up wrapping it all into a special landing page. There was another dwarf planet that was visited by a spacecraft last year, Ceres in the asteroid belt, so we have a landing page for both of them. It got a bit unwieldy in the end because we had so much Pluto content and not as much Ceres content. We probably should have maybe split those apart, but at the time we thought, how many dwarf planet flybys can you do in a year? So we'll put them together. So anyway, I just wanted to sort of describe that Pluto flyby as an example of how to do original content at a story that everybody else is covering, how to cover something in real time when you don't actually have that much material to work with, and probably just to underscore, I had sort of not planned enough for the photographer, but my editor said, let's send a photographer, and having those original photos of people in mission control was like amazing. So it reinforced to me that multimedia is not an afterthought. It needs to be integrated at the very beginning of a project. And I think we did that fairly successfully. Here is what Pluto looked like when we finally got the pictures back from that day. You'll recognize the bright colored heart in the middle of it. The daughter of Clyde Tombaugh, who was Pluto's discoverer, was very happy there was a heart on it. She was adorable. She said, I love that Pluto has a heart. And on the way back from that trip, after it was all over and I was flying home, that woman, the daughter of Pluto's discoverer, was on my flight, and I was lucky enough to sit next to her, and it was great to hear. So there were a lot of personalities wrapped into this Pluto story. This is just a before picture. This is actually Elliot Young's map of Pluto more than 15 years ago, before we knew what it looked like. And then that's what we actually saw. So you can see before and after. So now this is an explored world. It's no longer a mystery on the map. So that's one example, Pluto, spacecraft. I love spacecraft. I also love earth sciences because of my background. So I want to talk about other types of stories. It's not every day that you're going to be able to cover a mission to the last unexplored world in the solar system. I'm never going to get that again. None of us will ever get to write about that again. So how do you write about science at its more basic, at its everyday, this is what scientists do, and this is what the process of science is like? So my editor at Nature and I have been talking about ways to try and illuminate that more, not just, hey, here's somebody who found, a hot-blooded fish, which is really cool and awesome. But what's it like to be that person who discovered that? Or how do you get beyond a one-off discovery and illuminate the process more? So because I'm an earth scientist, I write a lot about earthquakes, and I write a lot about earthquake devastation. And I had been thinking for a while about writing about the team at the US Geological Survey, whose job it is to track earthquakes worldwide. They are the only group that does real-time seismic notifications for the entire world. They basically draw on the seismic networks of all the different countries and all the different agencies. They funnel that into their headquarters in Golden, Colorado, and they have a seismologist review every time, every single day. Somebody is on duty screening these earthquakes. And this is important because you get false signals, things may happen that aren't earthquakes. And there's somebody sitting there all the time in Golden, making sure that this map of real-time earthquakes is accurate and up to date. So why is that important? It's important because of emergency response. If you're wondering how big a quake was and how damaging it was, these are the folks who are going to tell not only the public, but also emergency responders. And so I had been thinking for, I think, like 2 years. I wanted to go down and do a lab visit and talk to these scientists. And finally, I think I had a quiet week, and I thought, I think I'll just schedule that. So I went ahead and scheduled a visit, like the following Friday, to come down. And of course, in the interim between when I scheduled the visit and when it was supposed to be, we had the Nepal earthquake last April, which was incredibly devastating. As you remember, nearly 9,000 people killed. Kathmandu was in not really good shape. The countryside was devastated. There were huge landslides that buried villages. It was one of the most devastating quakes in the Himalayas for quite some time. And I thought, crap, they're never gonna let me in. They're busy, right? Well, because they work so quickly, I had an appointment for Friday, and I think the quake happened on Tuesday. And they were like, no, we're done with the Tuesday quake. You can come on by. I'm like, great. My editor was like, what are we going to do about the Nepal story? I said, I happen to have a lab visit set up, so I'm like on top of it. So I looked really good to my editor, and I went down there. And We started asking key questions about how they do what they do. How did the Geological Survey establish the location of this quake and the magnitude of this quake so quickly? How do government officials use that information in responding to the disaster that was unfolding in real time? And most importantly, I wanted to look at how do scientists ensure that that information is accurate when seconds count? I mean, literally people's lives depend on this scientific information because the officials are making decisions about where to deploy emergency response teams based on their information. So if they get the magnitude wrong or they get the location wrong, the officials might not send emergency teams out, or they might send it to the wrong place. And when seconds count, whether you go down this road to get to that village or this road to get to a different village is significant information. So this was the key source for this story. This is Paul Earle. He runs the USGS 24/7 response in Golden. So we sent a photographer out. Again, the professional photographers, my God, they're so much better than I can do in the field. He's holding that iPhone. As you can imagine, this is a man whose job is to be awake all the time, responding all the time. So that iPhone is in his hand constantly. In the end, I did 2 reporting trips and spent 2 afternoons with him. And it was a very interrupted interview because anytime you would talk with him, it would buzz, he would look, there'd be oh, look, there's a 6.1 in Indonesia, we better go check on that. So it was not ideal interviewing, but it also gave details that we could use in the story, how he was just wedded to that iPhone, how he couldn't get away from it, how he lived only a block and a half from work, so that when a big quake struck in the middle of the night, he wouldn't even get in the car. He would just jog the block and a half so he could get in. When the Nepal quake hit, I had to try and reconstruct what happened. So I interviewed the seismologist who was on duty because it was in the middle of the night local time. And I interviewed Paul about how he'd fallen asleep next to his kid, reading him a bedtime story. And then his buzzer went off at 12:30 or whatever, and he ran that block and a half into work, and he just started working the quake right away. And those were details that I think really brought it home to people what it's like to be a scientist at the front lines. So here's the resulting story. This cover picture, which is a bit dark, has these geological maps on the table, and then this is how science is done, right? A guy in a dark room hunched over some lighted computer screens. That's how science is done. But he's there all the time and he's on the case. So you can sleep well knowing that Paul Earle is not sleeping well. I was able to interview not just him, but a number of the other seismologists who worked at the center. And because we had just had this quake in Nepal, it gave us a really good news peg, a tragic but appropriate news peg, to talk about why it matters that these people are here night and day. One of the products that the Geological Survey has introduced, and this is new science that they've just introduced in the past couple of years. You probably use this when you're reporting on earthquakes, if you have real-time earthquake coverage, or if you're trying to write about the latest quake. This product called Pager, what Paul Earle has done is gotten just a lot of background information about different parts of the world, different cities, the different building types, construction codes, and so on. And just working in the background when they have spare time, the seismologists have estimated, what would happen to, city X if an earthquake of, caused shaking of whatever intensity, how many buildings would fall down. So, and they've done this, any of the Mexican quakes, any of the quakes around the world. Within 30 minutes, they have this up, right? So you can look, and it's color-coded. A green pager means you don't really have to worry about it. Yellow pager means you might have to worry about it because there might be a lot of damage. And a red pager, like this, the red dot at the top of the screen, is bad. This is really bad. And for journalists, this is a great tool because I don't know if you ever have your editor sending you those emails like, should I worry about, this quake that just happened somewhere? Is it going to be a big problem? Well, now you can go to Pager and it will show you by the color whether you can tell your editor everything's fine or no, we're really going to need to start to put a reporting team on this. So this is something that they developed at the Golden facility at USGS, and so I was able to talk to the folks who developed this. And especially with the Nepal example, we basically unspooled the story of how the alert for the Nepal quake came into the center, how they started to determine how much damage there would be, and how they were in touch with groups like the US Agency for International Development to start deploying response teams from Kathmandu and elsewhere. So it was real-time science affecting real-time lives. So why do I think that story worked pretty well? Again, because we're bringing the personalities to life and we're bringing the real-time applications, the real-world applications of science to readers. So many people, whether you're in the government world or the journalist world or the public world or whatever, they use this information every day, but they don't know where it comes from. So I think the story was successful in illuminating, again, the story behind the story. And now, just as my third example, to conclude, I want to talk about a different type of approach. We've been talking about writing for a publication with a very sophisticated technical audience and trying to illuminate for them how their community works. But what about when you're writing for the general public? So my other big client is a magazine called Science News. It's a popular biweekly magazine that's been published in the US since the 1920s. It gets confused a lot. It is not the news arm of the journal Science. It is not the British magazine New Scientist. It is the American magazine Science News. And it has a small but really dedicated readership. It's lay people who just think science is awesome and they want to know all about it and they want to know everything. And if you're writing a chemistry story, they want every single detail of that chemical reaction. So it kind of tests you as a science journalist because you really have to explain every single thing about science in very, very detailed but lay people friendly language. So I also write for these. I was on staff for Science News for a bit, and I continue to write for them. They actually have a really great website, which no one ever goes to because they're so small and nobody knows them, but sciencenews.org. They have a strong science education component as well, too, because they're a nonprofit. And so they have a lot of explainers and insights, and they have a great Science News for Students website. I forget the URL, but it's just I think it's one of those tabs at the top. So if you have kids, or if you want to read science news at a slightly different level that's more geared towards curriculum, they will take stories that are in the news and rewrite them for students. So it's a great resource for learning and understanding about science. But again, I was looking for a story to write. The background, I've been through this, lay people who aren't trained in science, but are just very interested in it. And I pitched my editors there a story about this river. This is a river in Washington State in the Pacific Northwest. It's called the Elwha, which is a native name. And what we have here is we have a before and after picture. Now, the story of the Elwha is that it used to be dammed, and now it's not. So 2 dams, you can see in the upper picture, one of the large dams holding back the water, and then a year later, the dam had been removed. This is a deliberate, approved take down the dam project. And the goal was to try to restore the ecosystem downstream. It is by far the largest dam removal project in the States, although there has been a push towards taking dams down because in a lot of cases the hydroelectric power they produce is no longer needed, or because there are other ecosystem consequences that they are trying to reverse. So it's an environmental story. It's a story about trying to bring back to nature something that we have altered. This is a really bad map of what it is, but I think just the main point I want to give here is that You can see the coast at the top, and then the river runs up into Olympic National Park, which is a beautiful forested area, a wildlands. This is a couple hours outside of Seattle, Washington. And there had been 2 dams on the river, which are marked with teeny white dots, and behind them reservoirs had built up. And so both of those dams were removed at separate times, and the idea was to unleash the river and let it run free. There's been a long-running environmental controversy, of course, about how dams impact ecosystems. And in this case, it was even more complicated because there was a human story in it as well. There were the loggers who relied on the dams to operate their sawmills downstream. This is a huge logging area. It's the forested Pacific Northwest. Also, very importantly, the local Native American tribes, when the river was dammed, lost access to a lot of their salmon runs. So again, this is the wild Pacific Northwest where many species of salmon travel upstream to spawn and then out again to the river. And when the dams went in, it really messed up those salmon runs. And what had been an incredibly important food source for the Native American tribe was then cut off. So there were a lot of arguments about building the dams in the first place, a lot of arguments about taking them down. What do we do? Well, this is how it got taken down. These big crawler-looking machines came out and knocked out all the concrete. As you can imagine, it was a huge engineering project. I forget how much it cost, but it was incredibly expensive. So they took it down and they're letting the river run free. So from a journalistic perspective, it's a very complicated story. It affects many groups of people in many different ways. And from our perspective, another challenge was that many journalistic outlets had written about this time and again. The Seattle Times had an award-winning series about letting the river run free again. There's a documentary film, again, something about river running, a beautiful documentary film where the guy went out month after month and took video of the changing river as it was restored towards its natural state. So many National Geographic had done a big blowout on this. So why even go there when everybody else has done such a great job? Well, we thought about this at Science News and we thought, there's a lot of science here that hasn't really been covered so much because so much of the story is human and society based. Why don't we do a story about the science findings? Nobody's really done that yet, even though there have been Pulitzer series about it, but they haven't really talked about the science. So we decided to try and narrow it and focus on 2 aspects. One, sort of the sedimentology, what happened to all that sediment when the dam was released, just all this goop came rushing out and dramatically reshaped the river channel. And that changed so much of the ecosystem, including the fisheries. Those salmon who were trying to come upstream changed everything. So I decided to go in the field. I happened to be going up to Vancouver, Canada for a different conference that Nature was paying for, and I tagged on this reporting trip. And again, it was a US Geological Survey guy. Again, these guys are great. He spent all day with me in the field. I called and I said, I'd really like to see the river and the recovery. And he's like, oh, I'll take you out. So he drives out from Seattle and he spent all day with me, all the way from the coast where the sediment was pouring out into the bay, all the way up the river past the 2 dams that had been taken down. Behind him in the background, you can see this kind of, that this is the remains of the dam, the kind of 2 things coming through and then where it had been blasted through. I think it looks like J.R.R. Tolkien, like Lord of the Rings, like the lost monuments or whatever. And you can see that where he's standing, it's all muddy and flat. Well, that used to be the bottom of a reservoir. So he took me up and down through the different reservoirs that used to be there and the different dams. And he was great. So in the end, we wrote a straightforward feature for Science News, and we explored the sediment of the sediment changes and what happened to the salmon as they were responding. As part of the tour, we stopped off and there was a technician sampling the river to see how muddy it was, how much of the sediment was getting flushed downstream. And so we have a nice little scene in there about this technician lowering his, bottles every hour. He's got to get samples, so he's got an automated system that dips it in, and you can see how muddy it is and how turbulent, and how the sediment's getting carried. And that's very basic scientific information about how the ecosystem is recovering. We also, again, wanted to do some multimedia, but because I'm just not really that good at it, I took my iPhone and I did some iPhone videos of that super helpful guy standing in front of the dams, just getting him to talk about what we were looking at. I took a couple of those during our tour, and we managed to splice them together with some professional film from that guy who did the documentary I was telling you about. So Science News put together its own little, like a 4-minute clip or something like that, like a tour of the river. So that was another nice component to it as well. So once again, why do I think this story succeeded? Again, because we were in the field, we spent time there. We were able to hang out with the researchers doing their thing. And those moments give narrative detail that can enrich your story and really bring things to life. Again, because it was such a complicated story, had to interview just a huge variety of sources. So the sediment folks, fisheries folks, the Native Americans, everything. And I would just say that even though in one respect we were very late to the story because everyone else had written it, I do think it succeeded because we were able to talk about the science like nobody else had. So one lesson I took away from that was that even if you think everybody else has written a story better than you already, there's usually an angle where you can get in on it. You just have to find what that angle is. So those are my 3 stories that won that award. I really had fun doing all of them. They all were very emotionally fulfilling and professionally fulfilling to really look at the story behind the story. But maybe a couple tips just to reemphasize. We've talked about these before, but first, that story ideas can take years to materialize. I keep a long-running story list that goes so far back in time you don't even want to know, but I have used that, years later to resurrect a story or to have deep background on something that's now in the news. So the example there is Pluto, right? So I knew this guy from college, and I thought, he would be a great way into this new story that's happening. So keep those lists, keep those story lists. You never know when it's going to be useful again. Could be tomorrow, could be 10 years, but you might just write a really great story. Another thing I just want to mention, I'm kind of an evangelist for getting out in the field and doing reporting. I mean, I'm stuck in my basement like many of us are stuck in the newsroom on the phone so much of the time, and people are just giving us their line about what they think is important about whatever their new thing is. But getting out in the field is worth it. If you don't have much time, if you don't have a budget, find somebody local to go hang out with. Both the Pluto story and the earthquake story were local for me. Just had to drive, 20 minutes, 30 minutes. And I arranged basically repeat interviews that were not that long. I would basically touch base with them every couple weeks, go down, see them, go out for coffee or whatever. But those repeat visits built up the relationships with sources that kind of enable you to get the extra detail for your stories. So yeah, maybe we all don't have travel budgets to go around the world. We all don't have time to be doing, deep stuff. But look within your backyard for who those researchers are and what they might be doing. And if you can just hang out with them enough, something will come to the surface that will be unique and different. And finally, I guess, this has been my main point all along, that anything you can get to push beyond just the superficial level that the scientist is trying to give you will enrich and deepen your story. I think I was able to do that with these 3. And anything you can do to push beyond the press release, push beyond the line that they're trying to give you, will enrich your stories and hopefully give you clips that you're happy about at the end of the year. That's how I try to measure my success. I sit down at the end of the year, I say, what have I written about that's fulfilling and interesting and good and was good for the readers? And so I try and think about that when I pick stories, and I hope you do too. So I want to thank you all for having me. I do have a book about an Icelandic volcano, as she mentioned, so I love talking about volcanoes anytime. I love Popo here. It's great. Anyway, thank you very much for having me. I'd be happy to take any questions. Or I'm happy not to take any questions, too. Yeah. Thank you.
Hello, my name is Emiliano Rodriguez Mega, and I'm a freelance science journalist. And my question for you is, I wonder how you capture the details of your characters in your stories, like to bring them to life. Yeah.
So that's a great question, because we all have notebooks that are full of detail. Go ahead.
Just one thing, yeah, without falling into this stereotype of what scientists should be like, right?
So that's a really, really great question, and I struggle with that all the time. So what I do is when I'm reporting, I just take lots and lots of notes when I'm reporting, and then I filter it later. So when I'm in the field, I actually have trouble writing everything all the time, so I audio tape with the iPhone, and I take notes, and I do video when I can. I take photos as visual cues, so if I'm out reporting, I'll take a photo of the telescope observing room or the earthquake thing, so I use those as visual cues later when writing. So I take massive notes, and then when I sit down to write, that's the key point. What details are relevant to what you're trying to do? So for that quake story, I wanted to get the idea of, always on. So when Paul Earle, he wasn't even paying attention. He walked over and he put on the kettle and he brought out the freeze-dried coffee and he just started mixing it up. And he wasn't even and I said, I said something like, Folgers, the cheap freeze-dried stuff. He's like, I don't even taste it anymore, right? And he said that and I thought, that's it. That's my kicker. He doesn't even taste the coffee. He's got to keep going.
Right.
So what I do is I just have so much detail, and then I think, what's relevant to the point I'm trying to make? I have fallen into the stereotype trap many times. So I did one profile, and I had a lead with the guy had a messy office, and I just was like, he's got stuff all over his desk. And then that story ran, and I thought, everyone's desk is messy. That doesn't say anything about him.
Yeah. Okay, cool.
Yeah. Do you have any tips of your own, or?
No. I just wanted to know your perspective.
Yeah, I sit down and I think, what point am I trying to make about this character, and what detail illustrates that? And sometimes you have the great story or the great detail, but if it's not making the point you need to make, you got to kill it. I hate doing that.
Right, exactly. Okay,
Yeah.
Cool. Thank you.
Yeah, thank you.
Gerardo Cifuentes. Quiero saber si nos pudieras hablar un poco de tu libro, de Iceland on Fire, y cuál fue el proceso, cómo lo llevaste, imagino que es non-fiction. ¿Cómo lo hiciste, cómo lo escribiste? ¿Fue como un artículo muy grande o cuál fue el proceso de creación de tu libro?
Great. Yes, thank you for that. So my book is a nonfiction book. I wrote it actually with my husband, who is also a science writer. And we got started on that after the 2010 eruption of the Icelandic volcano that sent ash across Europe and grounded all the airplanes. So I went to Iceland for Science News to report a story about that. And when I was there, I heard about this eruption from the 18th century that had been much, much worse. So the book describes this eruption that happened in Iceland in 1783 and killed many people in Iceland, and it sent this massive poisonous cloud of gases across Europe, across England and Germany and France. It ended up putting so much into the atmosphere that it changed climate. It caused drought in Africa, which killed many, many people. It ended up changing the whole circulation in the Northern Hemisphere. It caused climate change for many years. So it's a nonfiction story, and we wrote about it as kind of a detective story. Here's a volcano that most people don't know about, but scientists have been investigating it and why it had had such a huge impact. There was an Icelandic volcanologist who had been in the field and had explored everything that had happened in Iceland. And then there were historians in England and France who had documented all the strange things as this volcanic fog came across Europe. So we put together all these stories that had never been compiled before into one place. My husband and I wrote most of the science stuff. My husband wrote most of the historical background. We're still married, and we co-wrote the book together. It did not come from a single article. It was always thought of as a full book. And yeah, it came out 2 years ago, and then several months after it was published, there was another much smaller eruption in Iceland that was very much like what happened in 1783. So we were able to write some newspaper and magazine articles about that new eruption that kind of built on what we had done for the book. Yeah.
Oh, thank you.
Thank you.
Hi, congratulations on your award. I'm Estrella Burgos, and I was meaning to ask you about when you don't have not nearly enough money. The budget is so low that you cannot, be on the scene to do your reporting. That's often the case in many media in Mexico and in the Latin American region. And so have you been there in that situation that you cannot go there to the scene, but you still have to write maybe a long story? How do you do that? What are your tricks, to supplement the impossibility of being there?
Yeah, so that's a great question. So I'm freelance now, so yeah, I don't have any money, so I do a lot of things by phone. And so, then you just have to make sure you talk to enough people enough times to try to reconstruct whatever you're trying to describe. So I do very long phone interviews, and I do repeat phone interviews with the same person. So I might call and ask them to talk me through whatever the story is about, and we'll talk about it. And then I'll sit down and, look at the notes and think about what I need to get, and then maybe talk to them the next week as well too. Now, a lot of us don't have the time to do that kind of thing either, but even just, talking to them, if you're on a really short deadline, a 30-minute conversation, and then calling them back the next day to follow up on some stuff, and just asking them. I'm sure sources hate me. I ask them the same question again and again to try to get them to explain, what did it feel like when you first saw whatever, or who was around when you made that discovery. So I kind of just keep asking them to tell me the same thing in different ways. And sometimes multiple conversations help with that, because they aren't like, I just told you that. Why you stop asking me the same question? If you call them the next day and say, I was thinking about what you said, and sometimes they'll come back. Yeah.
Thank you.
Thank you. Yeah.
Hola, soy Janine Quiroz, estudiante de la UNAM. Mi pregunta es, ¿cuáles son las características que tú puedes, o más bien que ustedes incluyen dentro de su narrativa en la revista Science? Es decir, si la narrativa tiende más un poco a ser como más divulgativa o periodística, y si puedes darnos características del uso del lenguaje, es decir, si utilizan metáforas, si lo hacen un poco más sencillo para la audiencia.
Okay. Yeah, so writing for the public is, yes, different tips and tricks for writing for a different audience. analogies are always important, or metaphors, or any way to sort of bring the complexity of science home to the reader. I'm trying to think of that particular science news feature. I didn't have any great analogies, but a lot of times when I'm reporting, I will ask the scientist if they have ways they describe their research to their spouse, their mother, their neighbor. How would they describe it at a cocktail party? Sometimes the scientists themselves have thought of really good ways to explain what they're doing. Like, well, space-time swirling around a black hole is like the water going down the drain. If the scientists themselves have not thought of those simple ways, then you have to sort of come up with them yourselves. So a lot of times I will ask scientists, well, this chemical reaction, if you have this atom and this atom coming together, I'll say something like, could you describe that as they're docking together, or they're having a dance, or they are flirting, right? Maybe they're thinking about getting together, but they're not there yet. So a lot of times I will sort of ask the scientist if my analogy is correct, right? Like, could you describe this as, the Starship Enterprise docking or whatever at a space station? So if they don't have good explanations, I'll come up with my own and ask them if they are correct. Does that answer your question?
Sí, un poco, si pudiéramos hablar un poco más, lo que yo pensaba es, me has respondido así, le preguntas sobre cómo hacerlo un poco más accesible para la gente, pero quisiera que podrías contestarme un poco más sobre si es un lenguaje un poco más como lo vemos, por ejemplo, en National Geographic, o si es un poco más sencillo, digamos, más directo, como más periodístico.
Right. So we try to, every story is different. For science news, we try to have language at a level about that of National Geographic. So we think a reader of maybe secondary school. So we try, there are certain words we don't use at science news, things that are too jargony. So we won't use technical terms, like we can't say isotope. We'll have to say a variation of a chemical element. So for when writing for the public, I have kind of a list of words I won't use like that. And I will aim at a level of readership, yes, I would say very similar to that of National Geographic. Basic language, simple sentences are very important. And usually I try to keep all the science details to one paragraph. So that way, if the reader is interested, it's all there in one paragraph. And if the reader is not, they can skip it. So that's another technique that I use to try and keep the language simple, is keeping the hard stuff in one place so people can either go through it or just skip over it, if that makes sense. Yeah.
Gracias.
Thank you.
Hello, my name is Manuelino, and could you elaborate a little bit more on the importance of the human factor even when you are reporting science?
Yeah.
I mean, you didn't really talk about quakes, you talk about a guy. And Pluto, you have the twins, and mm-hmm. What is the importance of the human factor? And have you ever been in the situation when you don't have a human factor and you need some other character which is probably not human?
Yeah.
Thank you.
So that's a great question. So there's a huge range of ways you can deal with personalities in science, right? So there's the straight profile type stories where it's just, here's somebody in the lab doing whatever. And I don't actually think most of those are that insightful because it's often just, here's one person doing one thing. I like to try and, if I'm using a person, again, I want them to do a broader job of illuminating something about science. So not just scientist X in their lab, but scientist X is discovering this, which is important because it's saving lives in the quake or whatever. I don't think I'm answering your question quite right. You asked about the importance of the human element. Yeah, so one of the things I like about writing for Nature is it talks about science as a process. So science is an incredibly human endeavor, and that is lost in so many science stories that are just like, oh, look at this gee whiz new discovery. Science is run by people who are stupid, ignorant, corrupt, bad at their jobs. Science is also done by people who are wonderful, terrific, smart, and brilliant. Huge range. So it's not just like science is a great endeavor that everybody is all happy and cheerleading. There are stem cell biologists who will stab each other in the back to get themselves published in one of these leading journals. And I love to write about that stuff. Competition, struggling, aspirations, every element of the human endeavor is reflected in the scientific process and what they do. And one of the reasons I left Science News, I like writing for Science News, but they were just all about what did they find? Nature's like, who are these people doing it and why are they doing it? And can you believe them? So we've written about reproducibility, scientists who go out and try and reproduce other people's findings and what happens when they can't. Does that mean the original work is wrong? Do they accuse those others of being wrong? So these are all elements of the human condition: jealousy, ambition, greed, and they all come out in writing about science in ways like that. I love writing about that aspect. Yeah.
Hi, my name is Itzel. I'm a science journalist student. And my question is focused in your research process. In all of those examples that you give us, have you ever had a problem or impediment about the government data or something like that? And have you ever been in risk? Because sometimes this kind of situation or stories, environmental stories, don't allow this kind of data, and how you resolve it.
Yeah, so that's a great question. None of the examples I gave are very controversial ones. They're very straightforward and easy ones. Some of the more complex reporting I've done has not necessarily been data, but more like when somebody gets, so I've written about sexual harassment in the sciences. So that's not really data-based, but it is controversial. So let me just talk about that for a bit. Last year, kind of a big scandal blew up, and this gets to the question of humanity in the sciences, of a hugely renowned exoplanet hunter who had been sexually harassing his students. And so reporting on that was very difficult because there were people who had stories of sexual assault that was difficult to talk about. You had to try to verify accounts of who said what, so it was not straightforward to do. There were a lot of difficult calls where you call somebody cold and ask them to respond to accusations. In terms of like access to government data and stuff like that, I did do some reporting on a big oceans story. The US government has spent a lot of money on an ocean observing system that many people were questioning. And so I filed the Freedom of Information Act requests to get correspondence about how that money was being spent and where it was going. And it ended up being sort of, many, like any Freedom of Information Act request, it takes many months and many battles. And a lot was redacted, stripped out when I got the information, and then I had to go back and say what's in there. So yes, so I have done some of those battles, and helpful to have a good editor in that case. I had an editor who had a lot of experience in trying to extract data from the government, and so we worked together to get on do the wording of the Freedom of Information Act request, and then when it came back denied, she had experience in knowing how to appeal. So it's very helpful to me in cases where you're challenging people to really talk with your editor at all aspects of their reporting.
Thank you.
Hi, Alexandra. I am Luisa from CONACYT.
Yes.
You told us about great stories you do for nature and science news. You have won important prizes, but I have a question. You didn't told us, how do you get to science communication and science journalism? Do scientists at least at the MIT or University of California have a science communication training, or did you have some special science communication training?
Yeah, so I can talk about that. So most of my training was on the job. So I studied geology at MIT, and then basically I got trained at University of California at Santa Cruz. So that is basically, it's like a master's type program in journalism, and that's where I took my first courses in writing news and writing features. And as part of that program, they had internships where we worked at local newspapers and with local universities. So by the time I graduated from Santa Cruz, I had newspaper clips already, because they put us in the newsrooms of papers in Central California, and we would write about, the price of carrots or whatever was happening at the city hall meeting, or, ocean pollution. There was pollution issues there. So that was where I got my first experience, and then I just worked my way up. I did many internships, including at the newspaper in Texas, and then I got a job at a small magazine, and then a job opened up at the paper in Texas, and because I had interned there before, they knew me and they knew my work, so I applied and got in there. So I just kind of worked my way up from internship, entry-level job, slightly better job, so yeah.
Okay, so when you were a geological, how do you say it? When you were a student,
Yeah.
Did you have some training? I'm asking because generally here in Mexico, scientists don't have that kind of training to talk about what they do to people like us, not to their peers.
Yeah.
So do you have that kind of training from the beginning, or?
Yeah, I did. I did a lot of writing. I took a lot of writing classes when I was at MIT. I took a lot of English and writing classes there. So I actually never really got far enough along as a scientist. I would not call myself a scientist. I sort of realized early on I wasn't really suited for that. I will say in the States there are a number of programs that kind of deal with communication for people who are PhD scientists. There's many fellowship programs. The AAAS has many training type programs for PhD scientists to do outreach in different fields. There are also specialties like the Aldo Leopold Fellows for Conservation Ecology. It brings scientists to kind of a boot camp to teach them how to communicate their work. There's another science communication type camp that has started up in California as well too. So I am aware, and I can give you a list if you want, of some of these training type programs that teach PhDs to communicate. In fact, one of my former colleagues at Nature who lives in England has her own company that trains scientists to communicate about their work. So I'd be happy to share some of those resources if you like.
Thank you.
Yeah.
¿Más preguntas?
Great.
Sí.
Yeah.
Okay, another one.
Yeah.
I was wondering because everybody is, general public, except in their field of their own specialty, right? So writing for nature, for example, maybe allows you to use isotope and words like that, and probably graphs and that kind of thing. But is there a difference in how do you approach to the actual story, not only about the words and the graphs, but the actual story when you write for a general audience or this kind of specialized audience?
Yeah, so, yeah, right. When I'm writing for nature, maybe I'm writing about astronomy, but the stem cell biologist has to understand it as well, too. So the stem cell biologist's understanding of astronomy is probably about the same as your general public, right? So when it comes to actually what I put in the story, maybe I can get away with isotope in there, but it's going to be not that much different. The things that are common across nature stories are, they're interested in the community. They want to know, how to work with data, what it means for their career if they get published or don't get published, those types of community issues. But in terms of writing, yeah, I may sit down and I may think I'm writing for PhD astronomers, but that PhD stem cell biologist has to understand it too. So, yeah, we have to keep it pretty simple, more simple than you might think. Yeah. So, great. Okay. Thanks for having me.